Here we have a very interesting problem. I particularly like this problem for reasons that we will see in a short while. Maybe the alert candidate will be able to eventually see the simplicity that lies in the solution of this problem. But let us go through the process, and when we get to that bridge, we will cross it. Before going into the manipulation of the fractions, let us convert the mixed numbers to improper fractions. The first one, as usual, we label the components of the mixed number. The whole number is the component that we label first. Then we have the numerator followed by the denominator. In converting this to an improper fraction, we will first multiply the denominator by the whole number. The result is then added to the numerator. So we have 4 multiplied by 2, and that is equal to 8. 8 plus 1 is equal to 9. Let us see if by the time we get to the next one, we will have anything to write home about. So the 9 will be the numerator of the improper fraction, and the denominator will be the same as before. 1 and 1/8. The same. Multiply the denominator by the whole number, which is the one that we have right here, and to that we will add the numerator. So 8 multiplied by 1 is equal to 8. Then we add 1, and the result is 9. 9. And the denominator is as we had it before. Then we go straight ahead and do the same with 4.5. 4 times 2 is 8, and 8 plus 1 is equal to 9. The 9 that we have calculated is the numerator of the improper fraction, and the denominator will be as it was before, 2. Well, it is quite remarkable that we have 9 over 4, 9 over 8, 9 over 2. But is that the information of greatest significance that we are paying attention to? The original problem, we have it right here, that we may make reference to it if necessary. Rewrite the expression with the improper fractions obtained on the previous slide. So there we have our improper fractions. What have we done? Apart from replacing the large fraction bar with a division sign and enclosing the upper set of fractions in brackets, we will rewrite each fraction with a denominator of 8. And how have we done that? As a matter of fact, we will take a look at this on a later slide. But how do we achieve that? We have 9 over 4. We are making use of the fact that 8 is the lowest common multiple of all the denominators, and we will use 8 as a common denominator. How do we achieve 8 right here? We have 4. To get 8, we will multiply by 2. Cannot just multiply by 2 in the denominator, we will be cheating the problem. Therefore, we multiply the denominator by 2 and the numerator by 2. So we have 4 times 2 is 8. 2 times 9 is 18. As a matter of fact, if we reduce this fraction by a common factor of 2, the result is still 9 over 4. Also, we have 9 over 2 as the lower set of fractions. What do? In order to get this to be 8, we are converting to the common denominator of 8. In order to get this to be 8, we multiply 2 by 4. 2 multiplied by 4 is 8. Cannot do that without multiplying the numerator by 4 also. So 4 nines, 36. So we have 36 over 8. By so doing, all the denominators are the same. It is easy to add the fractions right here because they are of the same denominator. Eventually, when we do the reciprocal, the fraction will be easily reduced by a common factor of 8. So 18 plus 9 is 27. 27 over 8, the reciprocal of this is 8 over 36. Immediately we see the 8's cancelling. The expression may be reduced by a common factor of 8, then by a common factor of 9. The answer is 3/4. Common factor of 9 right here. 9 into 27 is 3. 9 into 36 is 4. As mathematicians, we should not be opportunists, but we should not be afraid of making use of opportunities. Seeing that the entire problem may be written with a common factor of 8, not only causes the fractions to be added with great ease, but helps in the process of reducing the fractions in the end, where we have 8 cancelling 8. So by seeing that we have a common factor of 8, or we may write the fractions with a common denominator of 8, we see that in the end reduction is made easier, and also addition of the fractions was made easier. In the end, the process is very nice and spicy. On the next slide, we will take a second look at the process of writing the fractions with the same denominator. Here we have the set of fractions. It should not take much at this level to determine that they may be expressed with a common denominator of 8. We should be able to determine at sight that the LCM is 8. The LCM of all of these denominators is 8, and that will be the common denominator. Conversion to a common denominator of 8 should be a simple process and dependent on the simple principle that multiplying the numerator and denominator of a fraction by the same number does not change its value. Our first fraction is 9 over 4. Write it with a denominator of 8. 4 will be converted to 8 by multiplying by 2. The numerator will also be multiplied by 2. So there we have it, 18 over 4. Note the same with 9 over 2. Write it with a denominator of 8. 2 will be converted to 8 by multiplying by 4. The numerator will also be multiplied by 4. 36 over 8. The processes are simple and may be carried out at sight without any rough work. Be prepared to use these little skills in manipulating fractions. Fractions are not from outer space. They are regular numbers and may be manipulated quite easily if we are ready to expand on the principles that we have learned in primary school. I hope that although we have written this with a denominator of 8, that that does not affect the value of the fraction, because if we reduce this by a common factor of 4, the result will still be 9/2. There we have our arithmetic expression, which we need to express as a single number, or we are required to simplify that expression. What do? Multiplication takes precedence over addition and subtraction. It may also be advantageous to know that squares and square roots are of the same order as multiplication and division. Therefore, we will first multiply 3.96 by 0.25, and we will find the square root of 0.0256. Finish up by carrying out the subtraction process. That's all there is to it. Although square and the square root are on the same level of precedence as multiplication and division, and should be carried out before addition and subtraction, if a sum or difference is under the square root sign, then the square root sign should be treated as a set of brackets that encloses the sum or difference. That sum or difference must therefore be carried out before finding the square root. We do not have the situation that was just described. We do not have it right here. But in the event that we had a sum under the square root sign, before finding the square root, we would have to find the sum, treating the square root sign as a pair of brackets. Find the total cost of the rice by multiplying its unit cost by its mass. Right, so if we need to find the total cost of the rice, which is W, what do we need to do? We need to multiply the quantity by the unit cost, and that will give us the total cost. On the other hand, the total cost is equal to the quantity multiplied by the unit price. If we have the total and we need the unit price, we will have to divide that by the quantity. So here we are finding the value of X. Four multiplied by X, the result is 52.8. Therefore, in order to find X, we need to divide 52.8 by 4, and the result is $13.20. The Y will be analogous to X. This is similar to 2. Find the quantity by dividing the total cost by the unit price. So 14.1 divided by 2.35 is equal to 6, and 6 will actually be the quantity Y, may be the number of quarts of milk. Z is the percentage of the value added tax. We have the subtotal and the monetary value of the value added tax. Write the monetary value as a percentage of the subtotal. So here we have the monetary value of the value added tax, and we have the subtotal. This is added to this, and this is the result. What percentage tax is added to this? So we need to know $9.90 as a percentage of $82.50, and that is 12%.